Hi, I'm Terry.
Go ahead, guys.
I am Jorge.
Come on.
I'm Melissa. I'm Jocelyn.
Okay. I don't know if you can hear all of them, but
We can.
that's good. Okay. So then go ahead and explain what you're doing.
We're gonna transform wind energy into mechanical energy
How? What are you gonna do?
because we pinned a straw and attached a balloon to a pencil like this, and it's gonna be the mechanical energy thing, and then the balloon turning, it's gonna be the wind energy thing. And what we're gonna do is, what do you guys think is gonna be go farther?
Explain what you're gonna do though. You're gonna blow.
I'm gonna blow on this thing, blow on the straw, the balloon is gonna spin,
And
and
how much are you gonna fill the balloon up?
the first time I'm gonna fill it up half full, and then I'm gonna fill it up all the way full. What do you guys think is gonna make
Because
it
if you
spin
haven't told them
faster?
everything yet, how much time are we gonna time? How many times it goes around, right?
5 seconds.
So how many times does it spin around in 5 seconds? When it's half full? And then how many times does it spin around when the balloon is completely full? Which way do you think it's going to spin around the most times in 5 seconds? We'll give you a minute to write that and cover it live. So they're going to fill the balloon halfway with air and let it go and let it spin around for 5 seconds, and we're going to count how many times it spins around. Then they're going to fill the balloon completely with air and let it go for 5 seconds and see how many times it spins around. Which way do you think it's going to spin around the most? Or do you think it's going to be the same? What do you think?
So what I understand you're doing is once you blow up the balloon, you're not blowing into that straw anymore.
Correct.
Okay, and then we'll watch the whole thing spin and we'll see how do you think it's going to spin more, as a full balloon or a half balloon? That's what needs, whatever you think is what needs to go into the Cover It Live, which you don't have because you never got a computer. You're supposed to have one.
Yeah, we just gonna make it.
You only got 4 first. All right, are we ready to go then? Everybody had enough time to write?
No, not yet.
Yeah, okay, second then.
I'm ready.
Right, here we go. Go ahead, halfway. Okay, you guys are counting.
Okay, so here it goes.
Up? Huh? 4 times, all right. 4 times.
Get that in the Google Doc. It spun 4 times when it was blown up
Oh,
halfway.
sorry, mistake. It was 7 times.
Change that 7 times.
Okay, all the way up.
Let's go.
Terry doesn't pass out here from me. All right, that's probably good, Terry.
Alright,
Okay, 5 seconds.
wait, make the timer bigger.
Huge.
Look at the follow. So timer bigger.
It's okay, Terry, as long as it works, that's all that matters. You got it?
Alright, here we go. I'm starting.
Ready?
1.
We can't
Oh, wait, no, you
see.
have to.
All right, go ahead. Pull it back up.
And make sure you're holding the balloon in front of the camera, because otherwise we can't see
Yeah.
it spinning.
I'll make sure you Get it in the right spot. One more. Okay, that's good. Okay, and hold it straight up. There you go.
It's not going.
Okay. Sorry, I'm having timer problems.
We'll count 1, 2, 3, 4, 5. Done. I went 0 times.
Just leave it like that.
Okay, Terry, breathe.
All right, here we go. Go ahead. That's good. 1, 2, 3, 4, 5. Up 4.5, really.
4.5. How many of you predicted that more air would make it go faster?
I changed that.
Mostly everyone in the Cover It Live is thinking.
How many of you were right? Why not?
It might be heavier, the air.
Oh, so that balloon is denser, perhaps? So it weighs more?
And it's
More mass
It has more
that has to get around?
more air coming out of it.
In what, the big one?
Yeah, the big one.
Well, don't you think if more air was coming out, it'd go faster?
Yeah, but this one didn't.
But it didn't. Nick, what do you think?
That was kind of like us with our first try in this experiment. When we had the ball that was too heavy, the wind energy couldn't push it because it wasn't strong enough.
So you think the balloon, the mass of the balloon was so great that that wind energy couldn't push it enough?
yeah, we tried the.
There wasn't enough wind energy.
Oh, do you agree with that, Mr. Crosby's class?
Yeah.
Oh, you already had this discussion?
We did, because we did this a few weeks ago, and so we kind of knew, but we will admit that we had the same result. When we guessed the first time, we mostly all thought it would go faster with the bigger balloon because it was blowing up, assuming it would blow out the straw faster and push it around. And so we had the same thing. I have a feeling today, because we'd seen it before, most of us probably guessed the other way. But what were we thinking? They said the weight of the balloon. Does anybody remember what else we talked about that day may have had an effect?
Oh, we had too much air in the straw, couldn't push it all the way through, push it through fast enough.
Yeah, kinda, yeah. So that the straw kind of lets a maximum amount of air through, and so even though the balloon was pushing harder, it couldn't get that much more air through the straw to overcome the extra weight. Yeah.
The less air it had in it, it was easier for the air to come out of the straw because there was less air than more air.
Yeah, so definitely though, you can tell if you watch closely that the more full balloon was a lot heavier and it was dragging things down.
Wow. Mass beat out wind.
So that's one of those things, if you were really trying to design something like this to make energy or whatever, you would do a lot of experiments to find out where's that perfect spot where the weight and the amount of wind you can get through there are maximized. So if it's important for it to spin fast, you'd want to find where that happens the best.
When would it be important for that something like that to spin around fast? Real life. Think
on a
real life.
fan.
On a fan.
On a windmill.
On a windmill. So if we're creating a windmill and we want it to spin really fast because we want to get energy
On a
out of it,
helicopter.
do we want to make it heavy?
No.
But isn't it made out of metal? And isn't metal heavy?
So.
Well, there would be more energy to push it.
Right, there is more wind energy. We certainly don't want that helicopter to weigh, to be like iron. cast iron, boom, it would just fall to the ground. So we definitely, there are times we need to find the maximum mass we can have in an object in order
Without
to get
slowing it
it
down.
without slowing it down.